So we'll start off with alcohols and phenols. We'll discuss them together mostly, like wherever they have common properties, preparation methods and all, we'll do them together. And wherever it's not, we'll have it separately. Okay. And ethers, we'll do it in the end after alcohols and phenols. So as always, start off with classification. So you'll find, yeah.
Sorry, I wanted to ask, since you'll be taking classes the whole month, what's the agenda? Like how many, at least in chemistry, like how many chapters do you plan on completing this month, like in June?
Just a moment. Okay, so starting with classification of alcohols, you'll see a lot of, what do you call it? Overlap with whatever classification you had back in haloalkanes, haloarenes. Okay, so multiple ways of classifying it. The first one is based on this thing, number of alcoholic groups. Number of OH groups. तो क्या क्या हो सकता है? Can you guys take a guess based on what you already studied? So number of OH groups in the sense, if you have one OH group, क्या होगा?
Like mono, di, tri.
That's basically it. And because we're talking about alcohols here, so you call it monohydric, dihydric, and trihydric, polyhydric that way. You have monohydric. So if you have two OH groups, you have dihydric. 3 OH group, you have trihydric. And the general catch-all term for multiple is polyhydric. Okay, so examples of monohydric.
CH3OH.
Huh?
CH3OH.
Yeah, CH3OH. C2H5OH. Isopropyl alcohol. Like basically you can give any example that has just one OH group.
Can you write the structure for isopropyl? Like what when we see? Yeah. No, like so even if it's not isopropyl, this is alcohol, right? So even if there's when we say isopropyl for any other functional group also, so then where there's place, like where you've written OH, then we put that functional group.
Correct. So this is basically iso. So isobutane ke liye also you put a CH3 over here. So isopropyl alcohol is, so like wherever there's a T sort of a thing, you have a secondary carbon attached to the main thing, that's iso. Okay, so dihydric, we need two OH groups. So the simplest one, CH2, OH, OH. So these sort of structures, this is called glycol. So this is ethylene glycol because there's two carbon atoms. Okay, so wherever you have two OH group, that class of compounds are called glycols. This one specifically is called ethylene glycol. Okay. Then similarly, trihydric ke liye, simplest trihydric, you need three OH groups. So let's have three carbon atoms. OH, CH2 आना चाहिए. This also is CH2, OH. It'll be OH आएगा. So fourth is hydrogen. So this compound, this is called glycerol or glycerine. So difference is, the name of this particular compound, so in its purest form, it is glycerol, and the commercial grade, like what you see in stores, like what it is sold as, containing a little bit of impurities, preservatives, whatever it may be, that is called glycerin. So this is the commercial grade of glycerol. And polyhydric alcohol is something that all of you are pretty familiar with. So can you give me an example?
Miss, for glycerol, this particular structure that you've drawn, it will be propyl glycerol, or what would you say? You said that if there are two, like this three carbon one is called glycerol.
Yeah.
But then the one that you do for dihydric, you said it was ethylene glycerol.
That is glycol.
Glycol, sorry.
Yeah. So another difference between glycerol versus glycerine, like whenever you come across them, they refer to the same thing. It's just the context where you use it is different. So I've also read like British English, American English may difference hai. I've also read that commercially, like if it is 100% pure, you call it glycerol, but commercially it is also known as glycerine. But yeah, glycerine, glycerol, basically the same things. It's basically a byproduct when during manufacture of soap. Okay. Polyhydric, you guys give an example. क्या हो सकता है?
More than 3.
Yes. More than 3, multiple. Can you think of any compound you're familiar with that has many OH groups attached to it?
Sucrose.
Sucrose, like glucose, sucrose, they are polyhydric because they have multiple OH groups. And any random example? Yeah.
So glycol, is it an example of dihydric or a name? Other name?
So glycols, so dihydric alcohols are usually called glycols. So this particular one is ethylene glycol. So glycol tells you that, oh, there's 2 OH groups, ethylene matlab 2 carbon atom chain. As an example. So let me know once you're done with this, then we'll look at the next what do you call thing of this thing. Actually, there is a common compound. This is, of course, an example of this thing. So I was looking up examples of polyhydric alcohols. So if I attach OH over here also, so this is called erythritol, and this is one popular artificial sweetener. So this is derived from glucose. They're derived from sugars.
It's ERY? ERY?
Erythritol, erythritol. Erythritol. So sorbitol, xylitol, like all of these are multi-carbon OH groups. Have they told you what the pattern will be? Subjective, objective, 30 marks paper, 50 marks paper?
I think it will be 35, but I don't think we've been told the pattern particularly.
They've not mentioned in passing also ki kis tarah ka paper.
They've not mentioned, sorry?
They've not mentioned in passing also which like kis tarah ka paper hoga, MCQ.
Yeah, abhi tak not yet. I think she'll probably tell us tomorrow. We'll ask her.
Yeah. Yeah. Smera, Sia, Kaveri, once you guys are done, let me know. We'll go to the next. Sia and Kaveri,
1 second.
it's done? Okay. That means- ठीक है.
Done.
The next way of classification or basis for classification is based on hybridization of carbon. This is also exactly the same as what you'd come across in haloalkanes, haloarenes. Okay, so main types of alcohols you'll find is where the OH group is attached to an sp2 carbon or sp3 carbon. Let's look at sp3 first, and it may be attached to an sp2 carbon. So if we have an sp3 carbon connected to an OH group, pretty simple. Again, as always, you have your primary, secondary, tertiary. This is standard. So primary CH2, CH3, CH2OH, for example. Secondary carbon example, can you give me an example, Ska? You already noted down one secondary carbon example.
Ethylene, no, isopropyl.
Isopropyl is secondary, connected to two carbon atoms. So CH3, CHOH, CH3. And tertiary is again what you have. Just write it over here. COH. So tertiary mein it's connected all three carbon atoms. Okay. Then apart from this, we have. Do you remember when we were doing haloalkenes, haloarenes? Like what other types of alkyl halides did we come across?
Benzyl, vinyl.
Yeah, correct. So usme sp3 connected, which ones are those?
Allylic.
Allylic.
Yes. So what is special about allylic?
It's connected to sp3 that is next to a double bond.
Correct. So double bond and then carbon and then yahan pe. So this is an example of allylic. Apart from that, we have benzylic. So benzylic matlab we have a benzene ring. This is benzylic.
Didn't we have like common names for OH attached to benzene ring at different positions?
Yes. Abhi classification kar rahe na. When we talk about the names, we'll do that. No one's noticed yet. Benzylic sahi hai kya?
No, that's aryl. What you?
Oh, that is aryl.
Guys, don't just be blind. See that. See if you've noted it correctly or wrongly in your book. This is benzylic. Pay attention, guys. So at this point of time, like just put it on a post-it or something. So there's with respect to a benzene ring, there are some things you need to pay attention to. Okay. So if it is like this, so if you have a benzene ring and then a methyl group and then something connected over here, CH2, let's say, this is benzylic. So benzyl, like alkyl, that's also a substituent here. If it is directly connected to the benzene ring itself, halide alcohol, jo bhi hai. So then this particular thing will be called aryl, or more specifically a phenyl. Phenyl with a Y, not phenol. Okay. And if you have a benzene ring with a C double bond O and something connected here, then this is called benzoyl. OYN. Okay. So whenever you come across, like if any compound, its name is written down in words, pay attention whether it's saying benzylic, benzoyl, or aryl or phenyl, because three of them are quite different. Like if you have a benzyl chloride is different from a benzoyl chloride. Benzyl chloride is this.
So like phenol, sorry,
Yeah, benzyl chloride,
phenol is
oil chloride. It's an acyl chloride. Yeah. Yeah. Phenol.
phenol is arylic, right? So
Yeah.
so while naming we write phenyl or
So
arylic.
that directly has a name. Like this whole thing has a name called
Like
phenol.
suppose on you have some other like group attached to it, or if you have any other element or anything attached to this, then yeah.
So then this is what do you call it? Benzoic acid. This is a aryl OH group. Aryl hydroxy group. This is a phenyl hydroxy group. Okay. So just for categorizing it, little differences. Yeah. So
And you can have like one side chlorine and OH now. So then you call it chlorophenol. Phenol.
yeah, chlorophenol. Phenol, like OH takes precedence, so this becomes phenol. And
So that's still arylic, right?
yeah, still an aryl. Yes. So again, position numbers, all of that comes into picture. So if this is 1, 2, 3, 4. So 4 chlorophenol. Yeah, better have this also. Phenyl versus phenol. Yeah, just keep it somewhere. So pay attention to the spelling because all of these are valid and all of these mean different things. So when you're drawing the structure and all that, be a little careful. Okay, so यहाँ तक sp3 का हो गया. Now sp2OH. Yeah, इसमें ज़्यादा नहीं है. We have vinylic. Sorry, color difference. Yeah, vinylic मतलब what sort of OH would it be? This is pretty straightforward.
Double bond.
Double bond.
Like one with double bond, yeah.
Yeah.
Phenyl, it will be when the box is filled with an OH, right?
Phenol is specifically if it is OH.
Acha.
Phenyl is like even if you had like a carbon chain or just may benzene ring substituent ho. Like 1, 2, 3, 4, 5, like a really long one. So then this you call it phenyl, right? Like 1 to 4 phenyl heptane. So phenyl is anything that's directly attached to the benzene ring. Aryl chloride, phenyl chloride, that way. So usually use phenyl when the benzene ring becomes a prefix for something else. So suppose you have a carboxylic acid, this takes highest precedence, so you need to consider the chain with this. Or agar यहाँ पे benzene group hai, then this will be called 3-phenyl butanoic acid. That way. So phenyl you use as a prefix. Phenol, if it's phenol with an O, that's specifically benzene with an OH. Okay, yeah, so this is vinylic, then you have aryl. Aryl is when the OH is directly attached to the benzene. Ethers ka we look at
This we don't say first degree, second degree.
primary, secondary, tertiary.
Yeah, so in this sp2 we don't say.
sp2, if it is directly connected to sp2, it's vinylic. On top of vinylic, yes, like you can classify it as a primary vinylic or a secondary vinylic. If you have information यहाँ पे hydrogen है या if there's more carbons attached. That's why I drew a line over here. So primary, secondary, tertiary only deals with how many more carbons is this main one attached to. And allylic, benzylic, vinylic, like, okay, what else is going on in the chain?
Aryl mein there is no question of that.
Aryl is like, okay, chain matlab, wait, aromatic ring structure is, that's it. Benzene ring. Okay, now we'll look at nomenclature. Yeah. Sanskriti, Kaveri, Sia, you guys done?
Yes.
Yes, no, I'm done.
Kaveri, Sia, what happened to your videos? Nomenclature practice karna hai, like how deep do you guys want to go into nomenclature? Same rules as always apply. You need to consider the longest chain. Containing OH group, if OH group is the most important functional group there. Suffix kya hoga if OH is a suffix? If that's the primary functional group, this will be
All.
Oh, yeah. Oh, OL.
OL. Yes. Then if OH group happens to be a prefix, this will happen only if you have something like a aldehyde group or a ketone group or a carboxylic acid in the
Alkoxy, na, we say.
Hydroxy.
hydroxy.
Hydroxy, yeah.
ethers के केस में वो alkoxy बन जाएगा. 3-hydroxy, 4-hydroxy. Okay. What else do we need to know? Position, like yeah, whichever is the most primary one, lowest number आना चाहिए. हाँ. This is new. If you have more than one OH group, then how do you name things?
Diol.
Diol, triol.
So it follows alkane, जो भी है, propane, butane, hyphen, give the position numbers of both of these, and then diol. Diol or triol, how many ever there are. So use di, tri, tetra, etc. Okay. And when it comes to phenol, like common names where you have auto, para, meta, IUPAC name may you need to mention the position numbers. Some common names of diols and triols for phenols. And this is something that you have to know. So I'll just give you the names. So if you have a single OH, so this is called phenol. If you have multiple OH groups, so if like CH3OH, so this is called orthocresol. And if the CH3 and OH are in, it's called metacresol. And similarly, you have paracresol. These are all common names. Huh? So CH2OH के लिए simple ortho meta para, all of them are cresols. But if you have a diol, they have different names.
Can you go back 1 second?
So diols का common names. So अगर ortho position में है, so this is called catish. Catechol. Then meta position में is called resorcinol. Para position में is called quinol.
So what is the second one?
It's called resorcinol. Same thing, like it's a diol with OH in the meta position. This has a second
Are
name.
these used in?
Yeah.
Are these used in medicines or something? They all sounds like tablets.
I won't be surprised. Like either medicines or like mosquito killers, things like that. So this is also called hydroquinone. So quinone is a different class of compounds which has a double bond O. It's like derivative of aromatic compounds with a double bond O. And because you have hydrogen added to it, it's called hydroquinone. Also called quinol because again, OL is alcohol associated with that.
Resorcinol is used for skin disorders. Like you can
Oh,
apply it on your skin.
nice. Yes, Google it.
Yeah.
Yeah, that's cool. Okay, so now let's look at the structure. So alcohol defined by, you have carbon, and it can be either sp2 sp3 जो भी है. It is attached to oxygen and then hydrogen. Oxygen पे you have like 2 lone pair of this thing, 6 electrons, 2 bonds. Okay, so what is the hybridization of oxygen in this? Yeah, Kaveri.
sp3.
ऑक्सीजन का हाइब्रिडाइजेशन क्या होगा इसमें?
Oh, oxygen.
हाँ.
SP.
Okay, Sia
sp3.
said sp3, Kaveri said sp. What do you guys think it could be?
I think sp3.
Yeah, I think we count the lone pair also.
Yes, we do. Oxygen is also sp3 hybridized. So overall tetrahedral है, and the lone pairs occupy 2 of those and the bond pairs occupy 2 of those. So technically, like ऐसा, it needs to be like this. But for the sake of convenience, I just wrote it like this. Okay, so this is very similar to what happens in water. Like, in fact, you can think of, you can associate, like you have water in which both of them are hydrogen. Replace one hydrogen with a hydrocarbon group, you get alcohols, and replace the other one with hydrocarbon group, you get ethers. So you know, whenever you compare acidic properties, bond lengths, bond angles, and all, like water comes into the picture here. Okay. We're comparing bond angle and bond lengths. So the main types we have, so we'll be comparing regular alcohols versus water versus phenols. So first, bond length, how do you think they vary? So if you were to compare alcohol versus, like let's take methanol, for example, versus water versus phenol, what would be the length of the bonds in each of these cases? Right. So one easy one to figure out is phenol में सबसे ज्यादा होगा कि सबसे कम होगा, और will it be comparable to alcohols and water?
सबसे कम.
सबसे कम. Because double bond, partial double bond characteristic.
Partial double bond, yes. So lone pair on,
Because of resonance.
yes, lone pair on oxygen
I
is
said because of resonance.
resonance. Resonance means
didn't know.
partial double bond characteristic. So this will be the least. Alcohol, water.
I think water will have more than alcohol.
I think
No, alcohol will have सबसे ज़्यादा.
Water.
Water, yeah.
This is okay. I mean, water will have the lowest out of all because we are talking about bond lengths here. So hydrogen oxygen के बीच में hydrogen is a very small atom, right? We're talking about bond length, Kaveri, like hydrogen bonding and all will come with other molecules of water.
Sorry, I thought you were talking about the strength.
Where did H bonding come from? Kaveri, you said H bonding. किधर से आया H bonding?
I thought you were talking about the strength of the bond.
Yeah, so water will be the lowest because hydrogen is the smallest, or alcohol mein the bond length is going to be greater compared to phenol, and then water will be the lowest. This is going to be the order. Yeah. Bond angle. So bond angle, again, let's consider like oxygen, like the bond angle on oxygen is what we are considering here. Okay, this way. So this particular angle. So again, compare alcohols, phenols. What would be the bond angle comparison? Which one will be greater? Lesser?
Ma'am, could you explain why alcohol would have the highest bond length?
Yeah, could you? Yeah.
So bond length, we are talking about CO bond length. So water, in fact, shouldn't be in the mix at all, but like whatever. So alcohol will be greater than phenol because phenol may the lone pair of electrons gets involved with the resonance. So यहाँ पे partial double bond characteristic आ जाएगा. So this oxygen will be pulled slightly closer to it, तो ये length छोटा, like it'll become smaller.
But why is water
No,
even
compared
lesser
to
than
water.
phenol?
Yeah.
Water, because I mean, like compare bond length का meaning क्या है? How do you measure bond length?
The distance between the nuclei.
Right. So if you compare the distance between carbon nucleus versus oxygen nucleus and hydrogen nucleus versus oxygen nucleus, which distance will be smaller? Hydrogen by default is
Hydrogen.
small, so that's why it's in the end. Okay. Now bond angle. So if you compare alcohol versus phenol, what will be the nature of the bond angle? And यहाँ पे we're looking at oxygen का bond angle, this particular bond angle.
Will alcohol have more?
Alcohol will have lower. Okay. And the reason?
No, more.
Most.
Okay. And the reason?
Because of more repulsions.
Repulsions between?
Lone pair.
They're both. Yeah.
So
Lone
if
pair.
Oxygen का lone pair.
so if इनका repulsions ज़्यादा है, these are going to push on the bond, right? So will the bond angle become greater or smaller?
Smaller.
Right? So okay, you're talking, ठीक है. So you're saying phenol में the lone pair repulsions will be greater.
Ma'am, how do you figure out the bond angles for aromatic rings?
Yeah.
The
It is aromatic and oxygen.
So,
arrow,
how can the full ring be pushed like from because of repulsions? How is that possible?
It can, because
yeah, see, what is there in the ring? Like, what is the nature of the ring?
Delocalized electrons.
Delocalized electrons है ना? And lone pair में भी electrons है.
Yeah.
So, like, the lone pair is like this particular lone pair of electrons जो orbitals में है. This is also repelled by the electrons present in the ring.
Yeah, but not as much as the lone pairs are repelling each other.
So this is by default there in phenol and alcohol. यहाँ पे क्या है? So we have CH3. Is this visible or is this like extremely
It's visible.
सबको visible है ना? ठीक है. So this repulsion is there by default in both of these. लेकिन phenol में यहाँ से भी repulsion आ रहा है, which is not there in methyl. Like it has that normal old regular bond only. So in alcohols, like regular alcohols, methanol, ethanol, the lone pair repulsion is more than what you'd find in phenol. So the reason,
So the bond angle of phenol is greater than alcohol.
no, it will be lesser.
Sorry, ulta, lesser than alcohol.
Yeah. Sorry, the other way around. Because यहाँ पे lone pair repulsions are greater, no? So it's pushing against these bonds closer. Phenol में it's not pushing as tightly, like as closer. So this is going to be the order.
Yeah, because for the ring, if it's also repelling the lone pair, then that will also उसका छोटा हो जाएगा ना फिर. It'll move away from the lone pairs. Not only is there a lone pair repulsion, but there's also a bond pair lone pair repulsion, right? So it will move even closer to the edge. So the angle will be less, right?
No, it's not. So this lone pair repulsion is not as strong as it is in alcohol.
It's the same lone pairs.
No. And secondly, what?
Like, why would it be not? I understand if there's like other repulsions, bond pair or lone pair, but वो तो same ही रहेगा ना? Why would that differ?
This repulsion plus other repulsions. Secondly, यहाँ पे double bond characteristic आ रहा है. So यहाँ पे hybridization is changing to sp2. So that also increases the bond length slightly.
So in phenol, the bond pair, lone pair repulsions are there, so that would push phenol away from oxygen and towards hydrogen. That's why it has less bond.
Phenol has greater.
How does it have more? Yeah, that's my question. So how does it have more?
Exactly, yeah. So if it's repelling to it will go more towards edge, so the angle will be less, no? So how phenol has more?
Steric hindrance is also there.
अभी इसमें steric hindrance.
उससे ज्यादा
Because this
उससे
is
ज्यादा कैसे हो जाएगा? And मैं सीधा किधर से steric hindrance आया? Not reacting anything.
you have a whole ring structure here versus a single atom over here. Right?
Ma'am,
So
okay, 1 second. The lone, you said that the lone pair will be the same by default in both, and then phenol wale ka lone pair would be a
Same way, like this
weaker than-
repulsion is present in both.
yeah, but in phenol it's weaker than it is in alcohol, right?
It is weaker, yes.
Why would it be weaker?
Yeah, exactly. Because if the benzene ring is also repelling the lone pairs, it will move even more towards the hydrogen, right? So the bond
yeah,
will
so उससे कम
bond
हो
कम
जाएगा.
होगा. Yeah.
Two reasons. Again, benzene ring mein you have a partial double bond characteristic that is increasing the bond angle. Like oxygen default sp3 hai, like when all of them are single bonds. But when this lone pair is jumping over here during the process of resonance, it's changing into sp2 hybridization. So the repulsion isn't technically like just everything pushing away from each other. Like these two are interacting with.
So I didn't think that that bond would also go inside the benzene ring. Yeah.
Yeah. So that is why.
Then it's not repelling, no, ma'am.
But then how does it increase?
Yeah.
उससे बड़ा, yeah, हाँ, उससे कैसे बढ़ेगा?
What is the bond angle in sp2 hybridization?
Oh God.
What is the shape in sp2 hybridization?
Trigonal plane.
Trigonal planar.
Trigonal.
So three-sided, all in the same plane.
120.
120 versus sp3 में angle क्या है?
180.
Huh?
114 or something.
No, it is like a decimal or something.
Yeah, that's a tetrahedral shape. 180 किधर से? How? Oh God. You know what? I'm gonna give you guys a list of 11 standard topics to revise. Like take one chapter like every week, keep 1 hour aside for this, keep revising, because chemical bonding, so you'll keep getting it almost every chapter. Apart from that, physical chemistry may the topics of Ka, Kb, even in organic also Ka and all will get involved. You don't have to learn the formulae, but at least know what Ka is, what pK is, like how does it relate it to acid strength. So there are like a few things. Keep referring to that, okay? Because all of it is pretty interconnected. Okay, so sp3 mein it's a tetrahedral thing. Kind of looks like this. Like ये सबसे आगे होगा and these two are पीछे and then you have one here. Okay, So the bond angles in all the 4 cases is somewhere around 110 or
109.5.
something.
Yeah, 109.5.
105. So resonance is basically averaging out both. Like if it is a resonance between a single bond and a double bond, your bond length is going to be like 1.5 bond length. Your bond angle is going to be somewhere between both of these. Okay, so resonance causes averaging out of, you know, wherever the bond shifts from. Like agar single or double ke beech mein ho raha hai, to all the bond characteristics including bond strength are somewhere between single and double bonds. Okay, so yeah, so your bond angle ends up increasing it somewhere between 109 to 120, greater than tetrahedral. And yahan pe, because of lone pair repulsion, this is somewhere less than your tetrahedral bond angle. Like it'll be around 107, 108, something like that. Water may it went down to 104 degrees, right? If I remember correctly. But yeah,
I'm
it's
still confused.
Yes, even I.
what part are you confused by?
Get this angle wala part. Can you repeat that?
Okay, so we're comparing bond angle between phenol and alcohol. So bond angle, phenol mein kya ho raha hai? You have resonance, and this resonance is switching between single bond and double bond. Okay. Yeah, Arya?
Yeah.
Yeah.
Single and double. So all the bond characteristics will be between single and double. So that includes your bond length, that includes your bond angle, that includes the bond energy, enthalpy, like all of that. Okay. So now since we are talking about bond angle specifically, the angle between this is somewhere between 109 and 120. So basically greater than tetrahedral and lesser than your trigonal planar. Okay. Kaveri?
Yeah.
And in the case of alcohol, ideally, like all 4 of them form bonds, exact tetrahedral hoga. But because again, like 2 of them are lone pair of electrons, there's going to be lone pair repulsion. So this is going to end up less than your normal tetrahedral.
Ma'am, I understood why the lone pair repulsion in phenol is less than that in alcohol, because there's one bond that's participating in the resonance, which is
Yeah.
why understood. But because the bond is participating in resonance, that will also like remove the lone pair bond pair repulsion, because between the ring and the lone pair there will be no repulsion because of that.
No.
Oh, then understood. Then it will be greater.
End up being greater. Yeah.
What did you say?
I said that
When there is a double bond?
the lone pair repulsion in phenol is less than the lone pair repulsion in alcohol, because one of the bonds in phenol lone pair is participating in the resonance in the ring. So they'll be more tightly bound together because one of them is participating in the resonance. That's why that's also like kind
So
of.
see
हाँ,
the
तो
reason which Miss Gave understood. तो उससे angle बढ़ कैसे गया?
अरे
Because
तो
there is
अगर वो
less
टाइटली बाउंड
repulsion.
होगा और लोन पे रिपल्शन भी कम है तो एंगल ज्यादा ही होगा ना.
Okay. So we discussed bond length, bond angle. दोनों हो गया. Okay. So before we get to preparation, we'll do some questions based on nomenclature. Yeah.
Why are we comparing all this with water though?
So this will in turn affect your reactivity and other properties. Okay.
Bond length, and if bond length increases, like the relation between bond length and bond angle is directly, no? Or there is no relation as such between.
No, there's
The
no definition.
how? Okay.
एक length है, एक angle है. So,
No, like in hybridization, we said na ki the length of equatorial bonds would be,
That is
and then
not
we said about
dependent
90,
on-
120.
that is specifically in one case, which is sp3d2.
Yeah,
Not
the
like a
PCl5 one, na?
Yes, correct.
So that was only for that one, which is
Yeah.
specific for that compound.
There was a question that I had come across like in some Google form. Why is the alcohol's bond angle less than the normal one for tetrahedral?
Lone pair. Same reason why water ka bond angle is also less than normal.
Can you explain?
Okay, so we will have to go back to this thing. So tetrahedral geometry matlab, it's, let's say these two are in your regular plane, and this will come bahut aage, and this is like behind the screen. Okay, perspective. Now, do you guys remember when we were doing chemical bonding, you had this order, right? So the repulsions between lone pair is greater than,
Greater than lone pair bond pair, and that is greater than bond pair.
correct. So more lone pairs that occupy around the central atom, more repulsions there will be. So agar yahan pe, if we remove these two and make them lone pair of electrons instead.
Oh, so
I mean,
they'll have more repulsion.
Yes.
So the angle is more.
Yes, the angle is less. So these two will start like, because the repulsion between these
Okay, yeah.
they'll push, and this will become less than your normal tetrahedral angle. Okay. All right. Guys, open your phones. We'll do questions on Flipper. So introduction topic here, there's just 2 questions. So you guys do it on your own. Then we have a topic called alcohols. So we'll go live on that. Join in 479560. 7 questions. Hopefully we'll finish off in like 15 minutes. Yeah, Smera, Sanskriti, and Arya. Kaveri joining? Yeah. Okay. Glycerine has, answer in like 30 seconds, guys.
Ma'am, my app started updating and now it won't let me open. 1 second.
Yeah, ठीक है.
Yeah, even me.
Update होने दो.
I think just new update came or something.
How can in, nothing. Ma'am, we know based on the number of OH groups we can say mono, di, tri, but for how can we say for sure if one, like if it's primary or secondary?
So they've specified, no, glycerine. You know the structure of glycerine. So this is the structure of glycerine. So this is specifically glycerine. तो इसको देख के figure out.
How is that one secondary and two primary?
Yeah, exactly.
देखो, this is the structure.
One is attached to secondary carbon, two is attached to primary carbon. It should be CH2, right?
This should be CH. What sort of OH is this? How many carbon atoms is this attached to?
Is my name coming twice?
Did you rejoin or something?
No.
Like, are you guys clear on this question, Abhi?
Yeah, got it.
Okay.
So it's not that all trihydric ones are one primary, two secondary, or one
It
particular
depends on
substance.
where
That
they are.
glycerine is like that.
Glycerine is like this, yeah. Sanskriti. Answer.
In this, can you explain
Yeah.
why it's true a primary alcohol with a branch chain that one
Yeah,
is true?
Yes, ma'am.
A
Chris,
prime-
why is it not primary alcohol as C2OH group? There is CH3OH, no? That's not C2OH. What does
one
that
will
say?
be attached to another C, na? So CH2 hoga na?
That is, it has that group. That doesn't mean that's
Yeah, that is only CH3OH then. Agar there's one more carbon, then it'll be CH2OH.
primary matlab,
What does that even mean?
see, primary matlab, it has to be attached to only one carbon atom or none at all. Like if it is attached to none, that's only methyl alcohol, nothing else. Otherwise, primary is basically attached to one other carbon atom. These two cannot be carbon, has to be hydrogen.
If there is plus one carbon and then OH attached to it, it'll obviously be CH3OH because 1, 2, 3, 4 bonds. And then
No,
you
उसमें किधर C2OH group है?
minute. And if you're saying
CH2OH group.
CH2OH, not
हाँ, CH2OH.
What is
What?
this?
है ना CH2OH.
Oh.
Okay.
I did not
Could you explain why the first one
second
is
point. A primary alcohol with branch chain has minimum
Yeah.
of 4 carbon atoms. I did not understand that.
So primary CH2OH चाहिए, branch chain चाहिए. So अगर branch चाहिए, we can't have a straight chain. मतलब minimum एक और चाहिए and यहाँ पे एक चाहिए branch के लिए. So if I add a branch over here, then it won't be primary anymore. So this can't be counted. So I have to add a branch on the second carbon. So which means that 1, 2, 3, 4 carbon atoms to chahiye. Okay, so Sia and Kaveri got it correctly. This one. Secondary alcohol has minimum 2 carbon atoms. So secondary by definition is the carbon with alcohol has to be attached to 2 other carbon atoms. नहीं तो secondary नहीं होगा ना. So minimum 3 carbon atoms. होना चाहिए. Like you can't have two carbon atoms.
Can you explain that branch chain one again?
One second. Ma'am, if for the same one, if it's primary, so it's attached to one and then it's branched, so वो तीन होगा ना, चार कैसे होगा उसमें? Like I don't know how to explain, but
Because if
like
that
this.
carbon is attached to one, then it's
Is
attached
it
to
a
one, then
branch
it's a
or
straight
is
chain.
it a straight chain?
Oh, yeah.
चाहिए ना for a branch. Arya, you were saying something?
Miss, can you explain the branch chain one again?
Kaveri, do you want to take this?
Okay. So if it's primary alcohol, then OH and then one C, then we know that that C has to be attached to another C. Correct?
Yeah.
Till those are the first two ones. And then if you want a branch, you cannot just draw एक नीचे ऐसे because वो वैसे भी straight हो जाएगा. So you have to draw another one and then make a branch on it, and then it has to be minimum of 4.
Acha. Okay. Yeah.
Next question. Hybridization of oxygen atom. This is a direct question, like everybody has to answer correctly. Sanskriti.
Mom, I have answered.
Answered. Oh. Sanskriti, which one did you answer?
Mom, SP3.
SP3 is correct. Okay. Correct. Next. A lilac. Nice. Sanskriti answered or not answered yet?
Mom answered, but it's wrong.
A lilac is the one. C double bond C C O H. So this particular carbon सारे single bonds में ही है. So this will be sp3. ठीक है. sp2 अगर यहाँ पे attached है, so then this will be called vinylic. Vinylic. Next. Again, pick the wrong statement.
What is carbinol?
So carbinol was like the old time name of methyl, like if you had a CH2OH or basically a single carbon connected to OH So this is called a carbinol. Okay, so
dimethyl carbon.
dimethyl carbinol is COH has a dimethyl attached to it. So this fourth one will be a hydrogen. So this is dimethyl carbinol.
Where have you drawn carbinol का structure?
यहाँ पे. This one. So the carbinol part is the single C bonded to OH. If it is just carbinol, that's another name for methanol. अगर कुछ substituted है तो you use that as a prefix.
Ma'am, I'm really stupid, but what is hydroxyl group?
OH.
Acha, okay.
इसलिए prefix hydroxy when OH is like less important.
Yeah, I just pressed the wrong one.
Or did you press it because, oh, there's something new, maybe this is the answer?
Yeah, I wanted to experiment.
Okay. Smira, Sanskriti and Kaveri.
I gave.
Yep, ठीक है.
I don't know why it's wrong, but it's like the only not right one. So that's why I chose it. I don't know why it's wrong.
Phenyl methanol का structure पता है? What is it talking about?
No.
Again, look at the name.
Methanol to phenyl.
Phenyl,
Yeah.
methanol. So you have methanol, so single carbon with OH, और उसके साथ phenyl भी है. So this is the thing. So fill it up, CH2OH.
Oh, okay.
So here it is attached to sp3 carbon. इसलिए that is the wrong statement. Sanskriti, what happened?
Ma'am, I got confused with the carbinol one.
Yeah, so why? What happened?
I forgot
She
what I was
also wanted
thinking.
to experiment.
No, I seriously forgot what I was thinking when I selected the answer.
Focus. Pay attention. इसलिए I discussed क्योंकि carbinol is. Okay, next question. Okay. Let me know if you guys are able to see the question properly. Otherwise, I'll flag it.
Can't see at all.
Android guys.
I can see.
Okay. Can you like just click a screenshot? Will you be able to get out of the app?
I can see the options, but I can't see the questions. So if somebody
Where is the question? Oh, iOS display का issue है. They're working on that.
someone sending the question.
And any of you guys will be able to send it on WhatsApp?
No.
No. Sending them.
Thank you, Smera.
I sent, but I know you won't have to.
Thank you to you.
I'm not sending.
Okay. So CH2 is attached to CH.
This
What is this? question.
Yeah,
Like,
this is so
ऊपर
confusing.
के
The
line में
CH
there is something, नीचे के line में there is something else.
Yeah, I think it'll be better if they just upload it as an image rather than trying to type it out. So this is the structure. So we have CH2.
It's the CH2 double bond directly.
Yeah. और क्या है? Then
CH2.
CH2C.
HOH. CH and then OH.
ऊपर CH3 होना चाहिए ना फिर?
Yeah, it has to be CH3.
the CH2 would be on the
यहाँ पे CH3 होना चाहिए. Because CH2 would be wrong, like कुछ, then something would be missing. This is the structure.
no,
Wait,
it will be
it's
on the
given-
CH.
Yeah.
Then
the
that
CH,
it is on the CH.
Oh,
Yeah.
yeah.
What? What?
Valency.
Valency.
Not this one. The
No,
other.
not that, the other one in front of OH.
Ah.
That CH
Yeah.
would have. Yeah.
Oh, okay.
हाँ, C के ऊपर है ना, CH2, then C, CH3, HOH.
Ma'am, I have a doubt.
Yeah.
Like after everybody's done.
ठीक है.
Oh, what is this?
Yeah, I think I figured out here out. Sanskriti, yeah, got it. Huh? Yeah. What? Who said? What is this?
We are giving preference to OH over double bond, right?
Yes.
So what will be, if it's all at the end, what will we say for the double bond?
Double bond हमेशा is ene.
But अगर यहाँ पे अच्छा butanol. Wait, not but, sorry.
So
Oh
we're
yeah,
not
yeah.
giving preference to double bond here.
No, because
Last-
that's the functional
Last
group.
year you had told the double bond में lowest number जाएगा.
This is because यहाँ पे functional group है ना OH. अगर chlorine
OH,
वगैरह
yeah.
होगा तो then we won't give preference to halogens and all.
अच्छा.
Did I share the priority order का list with you guys back? Nomenclature 11th grade में भी नहीं किया.
It was there in 11th NCERT.
I'll share it. I'll find it and share it again. Quizlet तो दिया होगा ना? Like with the priority order, that link also is not with you guys.
I didn't do it.
What? What are you saying?
The nomenclature ka priority order is there, no, between all the functional groups.
Yeah.
So I was asking if I shared that in grade 11.
I wouldn't know.
I did because the link is purple and I saw it, which means visited it before. I'll send it again. Who else? Kaveri, you've not answered yet?
I just did.
Yeah. So Smera, was that your doubt? Priority order, double bond this thing, yeah. Okay. 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 Next, last question. This will take some time because you have to match 4 of them.
My image is loading. Can someone send the image?
Send.
Thank you.
Send it to me. Okay. Actually, you guys, I hope you know. If you want to magnify it, just click on the link here. Magnify हो जाएगा. Link नहीं, like click on the image, it'll get magnified.
That doesn't work for me.
Not for you. Like, let me know if it's not visible. I'll send the magnified.
No, she sent the picture now, so I can see. Why do they always give column B more than column A to make it so much confusing?
That's exactly why they give it, to make it confusing.
Sanskriti and Arya. Okay. Nice. 5 on 5. Everybody got it. Sanskriti Arya, you guys were not confident. Yeah, bhul gayi.
Forgot about double bond.
Yeah, it was a bit confusing, so I didn't want to.
ठीक है. Okay, that's it. So we'll start off with the preparation methods.
Ma'am, sorry, could you go to the bond angle wala slide one second? Oh, it shows the results now.
हर question के बाद
For me, it doesn't.
iOS updates are there. Don't worry.
Yeah, done.
ठीक है. Preparation methods. Yeah, 45 minutes. ना ठीक है. Couple of them. So look at preparation of alcohols first. Then we'll look at phenols afterwards. So the first few methods of preparation would be from alkenes. So alkenes का structure क्या है?
Double bond.
So we have C double bond C. So इससे if we want to get alcohol, we need to remove the double bond and add OH on one of them, right? So first one, direct addition reaction, is acid catalyzed hydration. This is reverse of, like if you remember preparation of alkenes. So how do you prepare alkenes from alcohols? याद है? याद नहीं है? So that was dehydration. You remove water and you get alkene. So this is reverse of that. You add a water molecule and you get your alcohol back.
Dehydration is
What do we add?
Water. So acid catalyzed hydration. The general reaction, you're taking an alkene.
Earlier, how are we removing the water?
That also with sulfuric acid, acid catalyzed.
Why do I not remember?
Yeah, but in this case, yeah, you're adding water back in the presence of an acid, H plus. So water is basically treated as HOH. H gets added one side, OH gets added another side, and you end up with an alcohol.
When did we do dehydration? Like in what did we use it?
Iska reverse. So alcohol like
Yeah, understood, but like
preparation of alkenes.
oh, ulta.
And this addition follows Marconikov's rule. You guys remember Markovnikov's addition?
Yeah, the H goes to wherever there are more number of hydrogen.
Correct. So hydrogen goes to the HOH may, this goes to the one where there's greater number of hydrogen atoms and OH gets added later on. Do you guys remember the mechanism of addition? Like we did that when I think chlorine was getting added, like preparation of alcohol.
Because of the stability of the carbocation.
So that's why like there is a possibility of rearrangement. Yes. So stability of carbocation will decide where, yeah, that's why H gets added to the
Secondary will be more stable than primary. That's
yes. Yeah, if you're taking an alkene, that is the case. Depending on how many branches there are, tertiary greater than secondary greater than primary.
but for mechanism, we always show it with a double bond only, no?
Yeah.
For triple bond, what would it be?
Triple bond, you get something called an enol, which tautomerizes to a ketone.
Oh yeah, tautomerize.
Okay, so mechanism. So step 1 is protonation.
So tautomers are those which like rearrange to get to become more stable, right?
Yeah.
So they're isomers only.
Yeah, because the same set of atoms only are rearranging, no? So same molecular formula, just different structures. Okay, so we have protonation, first step, addition of proton. So again, acids like protons don't exist independently, they always join up with a water molecule. So first we get the hydronium ion. So this gets attracted to the electron rich double bond. So plus H3O plus. So this bunch of electron attacks the positive charge. These two get attracted, which results in the formation of so like these two bonds will remain the same. यहाँ पे H add होगा, यहाँ पे this thing. Okay, exactly what happens is, let me draw out the structures. Plus H, H, H. Yeah. Like basically a proton gets added, then this positive charge is attracted to the double bond over here.
Isn't the arrow always supposed to be towards like edge?
No, so the arrow denotes the transfer of electrons. So wherever the electrons are moving and forming a bond. So if the arrow is towards here, so I've started the arrow from the double bond. So these pi electrons, the double bond breaks, and that attaches itself to the positively charged hydrogen. And this pair of electrons, oxygen is taking back its lone pair of electrons that it has shared with the proton. So इसलिए this is going towards this. Okay, so this particular, so again, the movement of electrons here is basically whichever is the more stable carbocation, that is willingly giving away electron, like that's okay giving away electrons. So the other carbon gets the hydrogen, and the one that gave away electrons will be left with this positive charge. And because the oxygen took back its pair of electrons, it's back to being a water molecule again. Then positively charged carbon is again attracted to the negatively charged electrons. So these electrons attracted, again, positive negative attraction, say, they form a bond with carbon. So that takes us to the next step. Okay, so I'll be putting the next step up in the next page. So let
1
me
second.
know once you're done with writing this.
How many do we have like this? Like from alkenes?
Acha, this we have alkene se we just have acid hydration, hydroboration, oxidation. Do we have?
No, no, no. I mean, not the reactions. I'm saying ऐसे कितने हैं from alkenes, from this, from that.
Oh, so we have from alkenes, reduction of carboxylic acids and all. See how we won't do. Grignard reagent here. 3.
Only 3 for preparation.
But now, there's one mercury related also. Let me see if I can find that. That's also oxidation only. So that relates to this. Oxymercuration, demercuration. That is also there. That's also related to alkene only. If you want, I'll give you guys that also.
What is happening with the, so the O is taking the bond. So O will take 2 electrons.
Yeah. It gave 2 electrons, it's taking back its 2 electrons.
When did it give 2 electrons? Acha. No, it gave only 1, not to H, and then it's taking both.
It gave its pair of electrons. 2 electrons. इसलिए positive charge है ना? H plus, matlab it's just a proton. It doesn't have any electrons with it. So both come from oxygen. Okay.
Oh, huh.
Arya completed?
But ma'am, it's taking na, so how plus charge?
After taking इसलिए neutral हो गया ना?
No, no, the O, it's taking the pair of electrons back, right? So it will have minus charge, no?
Because it gave neutral से positive हो गया.
Yeah, right.
Electron short. Then it
Oh,
took-
so again positive symbol.
Yeah. So that brings us to step
1
2.
second, ma'am. Just 1 second. Yeah, done.
Step 2 is nucleophilic attack. Basically, whatever I highlighted in the previous thing. So you got your water molecule back, oxygen with its electron-rich thing, and the hydrogen got added. In the process, a carbocation is formed. So this pair of electrons gonna get attracted to this. So can you guys identify what is the nucleophile here?
O.
Oh,
Water as a whole, the species, this is the nucleophile.
How water?
O is not separating out from hydrogen and attacking alone, right? Like water as a molecule is coming and attaching itself here.
Yeah.
Okay, that's fine. So now this becomes like all of this remains the same. Yahan pe, apart from these two, we have an oxygen attached here, which also has two hydrogens. And because it gave its lone pair of electrons away, oxygen pe positive charge. So which brings us to step 3, just deprotonation. Okay. हो गया? Kaveri and Sia?
Yeah, done.
Sia?
Yeah.
I think Arya is still noting. Okay. So deprotonation is removal of proton. So similar to what happened pehle, so we have this structure. Oxygen being electronegative, like it will take these electrons back and this is removed as a proton. So this will give H, H plus H plus. Technically though, this is again because H plus can't independently exist, medium में water molecule रहेगा, right? So one of the water molecules will pick up this hydrogen and technically you get H3O plus. Okay, but essentially one proton is removed. Let me know when you guys are finished doing, then I'll ask you 2 questions related to this. Sanskriti, Kaveri, Sia, you guys finished writing?
Why are we protonating it just to deprotonate it again?
What?
Why are we protonating it just to deprotonate it again?
We're not taking back the same hydrogen, no. Protonation happened at this carbon. Deprotonation is
Yeah.
happening from oxygen.
But why do we have to deprotonate?
Because this whole thing is unstable. The only way this can get stable and neutral is so that only when hydrogen comes off.
Okay.
Okay. Question 1. What sort of an addition is this? Like electrophilic addition, nucleophilic addition, or does it not come under any of these categories? If you want, I'll show you the first step if it helps.
Nucleophilic, right?
Nucleophilic.
Oh. Smera, Arya, Sanskriti, what do you guys say? Electrophilic hoga या nucleophilic hoga? Or is it like none of these?
Yeah, electrophilic and
This type of addition, is it an electrophilic addition, nucleophilic addition?
I think nucleophilic.
Okay. Sanskriti, Arya, do you guys say the same thing or different?
I only said nucleophilic.
You said nucleophilic. Kaveri and Sia also said nucleophilic.
Like which step? This one, right? Deprotonation.
No, overall, like we say, okay, follows Markovnikov's rule for addition, and this is like a general addition reaction, right? So, is it an electrophilic addition or a nucleophilic addition? Oh, chat pe somebody sent. Sanskriti also says nucleophilic. Okay, Smera, what do you say?
Yeah, I think so too, but I'm not sure.
Okay, good. So whenever you have to figure out whether something is like substitution, addition, जो भी reaction है, would you categorize it as electrophilic or nucleophilic? You need to look at the first step. Like पहला contact of the organic molecule किसके साथ हो रहा है? Is it with an electrophile or a nucleophile? Like what is pushing things off? यहाँ पे it is attracted to the electron rich double bond, right? Like the whole thing is occurring because a positively charged, like a proton, is being attracted to the electron rich double bond. So this would come under, this is an example of electrophilic addition. Kyunki the first thing that is getting added is an electrophile, an electron deficient hydrogen. So that's what is getting added first. This is what is kicking things off. That's why it comes under. So nucleophilic substitution it is the nucleophile that's triggering the reaction, so to speak. It's a nucleophile that's getting substituted and everything. Here, the first one to get added is the electrophile. So this is an example. This would come under an electrophilic addition reaction.
Wait, but you're adding water. Water is a nucleophile.
Yeah, you only said before.
In this particular step, a nucleophile is attacking this particular species.
How
But-
can the same thing be two different things?
It's not two different things. It is not a nucleophilic addition. I started off by saying you categorize things by seeing what triggers the reaction, what is getting added first. The electrophile getting attracted to the electron-rich compound is getting added first. That is why this comes under an electrophilic addition.
This is SN2.
No, SN is substitution. This is addition.
Oh, right.
Miss, can you explain again that part that you said for the first step?
So first step,
Yeah.
acid catalyzed में, the proton that's there, that's getting, so this is an electrophile, positive charge
Yeah.
So that's getting attracted to the electron rich region in the double bond. यहाँ पे pi electrons है, ऊपर नीचे पूरा electron cloud है. So because an electrophile is getting attracted to the electron rich compound and getting added to
So
it.
that will,
So that's why it
so
comes.
that will take one electron from, like take electrons from the double bond.
Yeah.
And that's why the single bond ho gaya.
Yes.
And it will get a positive charge.
Because it's losing that shared pair. Yeah.
Oh, and it gave, उसमें से एक H, it went to the, yeah.
Okay. Question number 2, like because of how the this thing happens. Like suppose you have a compound like this. Suppose you have an allylic alkene. So we have CH2 double bond C. Okay, suppose this is the alkene we have. And
This is an allylic what?
this is not allylic because it's a complete hydrocarbon. Okay, it's not anything. This is the alkene we have, and we do the same thing. Acid catalyzed, add water molecule. What product will be formed as a result of this?
The double bond will break and then the CH2 will become CH3.
Okay. And where is the OH added?
In the other one, like the CH.
Second one.
Yeah, the second one.
I'll give you 2 options. Or this. Which one will be the product?
Technically, it should be the first one, but I think it's the second one because of stability or something.
Yes.
The first one and the second one are tautomers.
Not exactly. So, like, because of how the tautomerization will not take place, like they're not constantly switching between those two, either this or this. Both of these are isomers, yes. Position isomers because they're differing in the position of OH. You wouldn't put them under tautomers.
So in tautomers, it's constantly like switching?
Depending on this thing, like one form is more stable than the other, but if at all you introduce it to a chemical reaction or something like that, it can switch back also depending on the external conditions.
Oh, okay.
Okay, now because of how the like mechanism is, during the mechanism यहाँ पे carbocation form हुआ ना, and we know that tertiary carbocation is more stable than secondary carbocation. So during the mechanism, if there is a tertiary carbocation just adjacent which is easily formed, like hyperconjugation, say this H can shift over here and you can have a tertiary carbocation. So that is going to happen during the mechanism, and that's why you get the more stable product. This will be formed here.
So will it be like major, minor, or only the second one would be formed?
Major, minor hoga, but this would be like pretty negligible. During the collision, like if you know, if a water molecule collides before this rearranges itself, like ek to form ho sakta hai. This is the major problem.
So if they ask, like, if they give this compound and tell us to find the reaction, then what do we give? Both or only one?
So you can write the reason. So this it's going to rearrange spelling ARRANG to a tertiary carbocation due to stability, because this is more stable. So again, like because it is adjacent, that is possible. But if this tertiary, like this particular group was somewhere after like 2 or 3 carbon atoms, then that would have been more difficult. Like that won't take place. That rearrangement won't happen. Because it is next to it, like hyperconjugation, those sare effects will take place and that rearrangement will happen. This is something I think we observed in alkyl halides reaction also. Like that's why allylic is a special category that we recognize. Like allylic ke case mein, so because you know, like direct hydration, say there are two disadvantages. One is it's a reversible reaction. Acidic medium matlab dehydration bhi ho sakta hai. And the second is, in this sort of a case, rearrangement bhi ho sakta hai, which is why we have other ways of producing alcohols from alkenes. So those two are pretty straightforward. Like we won't go through the whole mechanism of it. Usme the more important bits are the reagent that you use and what is the sort of final product you get. Okay. Let me know when you guys are done noting. Then we'll look at those other two methods. Yes. Sanskriti finished writing? Okay. So the next method, call it B. Right. So this is called oxymercuration, demercuration. Isme the main bits of it is you just know what are the reagents and what sort of product will be formed. That's it. So isme you start off with an alkene. Two step like this usually happens in two steps. The first step is oxymercuration. So you have a mercury related reagent. Usually you use mercury acetate. So it's HgOAc. Mercury acetate. Then in the presence of water and
This is also from. Oh, nothing.
so this is the first step. Like this will cause oxymercuration, and for demercuration, it's basically reduction. You're removing the mercury and extra oxygen, like the acetate bits of it. So you use NaBH4, sodium borohydride, sodium borohydride in a basic medium, OH minus. So again, like across the double bond, it's basically addition of water. You have hydrogen added on one side, OH added on one side. This also causes a Markovnikov product, but with no rearrangement.
HgO. What is after O?
AC, acetate. Acetate, CH3CO.
As in CH3CO.
Yeah.
So in the first step we use that, and then the second step, what is that 1 and 2? Like that's what it means, right?
Huh. So pehle oxymercuration hoga, where this mercury acetate is added and you have like a cyclo thing, which is what like stabilizes it and it will prevent the rearrangement. And demercuration is basically the reduction bit of it, where you take away the mercury acetate bit of it, you leave just the OH and H.
So we're adding mercury first and then removing.
Yeah. That's why it's oxymercuration and demercuration. So you leave the oxy behind here.
Do we have the mechanism for this?
No, like it's a little complex. So if you want, I'll share the mechanism if you're curious. But
I think it would be better to understand if you
okay.
like not learn it, but if you could just show it.
Huh. Oxymercuration, demercuration, mechanism.
What is written? What is the name of the first one?
First one?
Mercury. Yeah, the first reagent.
Oh, so HgOAc twice. So like acetic anhydride and acetic anhydride, that is bonded to Hg2 plus.
No, like the name mercury. You said some.
Oh, mercury acetate. An image. Here. Written? Okay, so this is the mechanism. So mercury acetate, He2 plus, these two minus negative ions hai. So because He2 plus, it acts as a Lewis acid, it's electron deficient, gets attracted to the double bond here. So you have this sort of a complex being formed. So ye bond break ho raha hai, like OAC minus will be there, like acetate ion in solution. Mercury and OAC is forming this sort of a complex. Then water attacks the more substituted carbon, just like you have the nucleophilic attack like that.
You have to remember all this.
No, you don't. I just showed it because you are. So basically, this is the step why the rearrangement will not take place. Like mercury is forming this sort of a complex that prevents the rearrangement, that protects this thing. So OH and H get added wherever, like at the double bonded carbons itself instead of anywhere else. So even if you have a tertiary carbon, like this is gonna prevent the rearrangement. And then the rest of it takes place, like OH is added. Then this part, you want to remove the mercury. So this is the reduction, the demercuration bit of it. So mercury is removed. That's why you use sodium borohydride, source of hydrogen, you get your alcohol.
So I didn't understand where is the water attacking on that C plus,
Yeah.
and where is the one?
Follow the
Yeah, no,
arrows. Yeah, the arrows show you how the electrons are moving.
And what is the second one showing? Like the third, yeah, the last one after that. Yeah.
So
What is that small arrow over there? Yeah.
oh, this is the deprotonation bit of it. Like whatever happened during deprotonation in the previous mechanism, same thing. So यहाँ पे जब water add हुआ, oxygen is getting a positive charge, right? Because the lone pair it donated to this carbon.
Yeah.
So it pulls the pair of electrons from a hydrogen, which another water molecule takes. So you'll be left with OH.
What?
Array, it's this step, Arya.
Miss, I understood you said that वो C plus को इलेक्ट्रॉन देगा H2O O में से. So वो H2O के O को पॉजिटिव आ गया अब.
यहाँ पे जो हो रहा है, that's exactly what's happening here. O को positive आ गया. So this oxygen is taking a bond pair of electrons, leaving H plus away, which is taken up by another random water molecule.
Okay.
So here also the same thing is happening. So
Yeah,
the oxygen is taking a bond pair, so leaving the H plus, which is taken up by water. So another.
And now to remove that acetate, we will use NaBH4.
Yes. Yeah. So this whole thing is oxymercuration, and this part is demercuration. So demercuration happens through reduction. Okay. And oxymercuration, demercuration hai. And the third thing, what if you wanted an anti-Markovnikov product? You use hydroboration. Yes. Hydroboration oxidation. So hydroboration oxidation में you take an alkene. Again, always the source is alkene. Again, this also, you have two steps. You have a hydroboration bit and you have an oxidation bit. Hydroboration involves boron. So the reagent that you use is diborane, B2H6. Have you guys come across diborane before? P-block elements, have you studied by any chance?
Don't remember.
No? Okay, so diborane is
No, but we have not done this. This part as far as I remember.
Okay, so diborane is a molecule. It is B2H6. Sometimes it's also written as BH3 taken twice. So basically you have boron. Again, it's an example of an electron deficient compound. So you have boron with 3 hydrogens bonded to another one, and you have another boron with 3 hydrogens, like something like that. So you have 2 borons linked to each other, 3 hydrogens on each side. So it's called diborane, B2H6. So यहाँ पे boron gets added, like boron and hydrogen gets added across the double bond, and the intermediate you get is called trialkyl borane. So it's basically substitute the hydrogens for the alkyl bit of it. So I'll take an example here. So that'll be easy. So suppose I have CH3, CH double bond, CH2. Boron always gets added to the corner. So you get CH3, CH2, CH2 taken thrice B. So this is trialkyl. So यहाँ पे because we took a 3 carbon atom molecule, यहाँ पे this is tripropyl borane. So this is the hydroboration part of it, because you're adding a hydrogen and a boron to this. And next comes the oxidation part of it. So oxidation is done using peroxide. So H2O2 in a basic medium, NaOH aqueous. So this will give you alcohols. CH3, CH2, CH2, OH. So the speciality of this, like why do we use hydroboration oxidation, is if you want an anti-Markovnikov product. So that's it for preparation for alkenes. Next class we'll do carbonyl compounds and the rest. So both these oxymercuration, demercuration, you don't have the exact mechanism. You just need to know what the reagents that you use are and what are the products that you form. Isme it follows Markovnikov addition only. Main thing is that there's no rearrangement. That's why you use oxymercuration, demercuration. Hydroboration oxidation ke liye you use this method if you want an anti-Markovnikov product. Reagent used in this is diborane for the hydroboration part of it, and oxidation will take away the boron, give you the required alcohol. So oxidation, you do it with peroxide and sodium hydroxide. Byproduct in this, so after removing this, you get sodium borate, Na3BO3. So BOH3 aa jayega, but because you have this also, you end up getting the sodium salt effect. Sodium borate. So the reason why you end up with an anti-Markovnikov product is when diborane is added, it like boron is added to the carbon with more number of hydrogen atoms. That kind of that gives you the opposite of what your normal Markovnikov is.
Miss, what is the valency of boron?
So boron is +3, but it is electron deficient. It acts as a Lewis acid. इसलिए you have BH4, and that's why this behaves the way it does. Just like
BH3, उसका पूरा valency है ना?
uska okay, boron is what 5, right?
Yeah, 2,3.
But boron is like that exception wala case where sometimes it
So 2 is TK, this is completely full. How the 3 is like you have 2 of them in 2s and 1 in the 2p orbital.
2p, yeah.
So इसलिए it has those Lewis acid tendencies. Same is the case with aluminium. Like even though
You
aluminium,
missed one.
oh yeah, I didn't miss one. I added one extra.
Yeah.
Yeah. Just it gets into the habit of pairing electrons. So, yeah, good catch. Aluminium also same thing. Like AlCl3 is a Lewis acid because it has like it is electron deficient. Like it wants to fill up the p orbitals also. Yeah. The same is the case with both.
Could you show the previous one?
That is the reason I've put this particular bond in dotted lines. So it dimerizes. Like BH3 proper, like ideally fill ho gaya, but because it's electron deficient, it kind of. Let's see diborane structure.
This what is after Na? What is that? After alcohol, what is the next?
So this is the byproduct. So this I'll write it. This is Na3BO3. So this is sodium borate.
Ma'am,
Hmm?
it's 5:30.
Yeah, so this is the last one. That's why I'm gonna stop it. So once you guys are done noting this down, we'll have an end to it. I'm not
Done.
up anything extra. It's electron deficient, won't form a bond. So it dimerizes, but it's like you have D H B H H. So यहाँ पे it's kind of this is the kind of structure it has. Let me go when you guys are completely done. Okay. We're gonna take 3 more classes for this circuit. Guys, we done? Any questions? Anything? No? Okay. So we'll end the session.